In this lesson, we're going to be looking at graphs and how to read information off of a graph. First of all, we're going to determine whether or not a graph could be a function. And to do that, we use the vertical line test. I'm sure you're familiar with this from Algebra 2. If any vertical line hits the graph more than once, it is not a function. Next, we're going to be taking a look at domain of a graph. Domain is the x values. It's the input. It's what's okay to put into the function. In our last unit, we looked at a lot of domain restrictions where there was division by 0, and that will show up in the graph. Finally, we'll take a look at the range of the function, or the y values, or the output. What answers do we get when we put x values into the function? And we'll look at how to read that off of a graph as well. As I mentioned, our focus today will be on reading information from a graph, so that's our essential question. First thing we're looking for on this graph is the domain. When you're looking for domain off of a graph, it is the x values. It's what's okay to put into the function. And one way to look for that graphically is by thinking about placing a vertical line on the graph and sliding it side to side. Anywhere that vertical line hits the graph, whether it hits it more than once or not, this is not about whether or not it's a function, anywhere that vertical line hits the graph is part of the domain. So taking a look at this graph, we see that we have x values from 0 all the way up to just past 120. We also have these arrows on our graph that indicate it will continue to move side to side forever. So that means the domain of this function is all real numbers. For the range of our function, we can think about a horizontal line sliding up and down the graph. Wherever this horizontal line hits the graph is part of the range. It's the y values of the function. Again, those arrows say that our graph will continue to decrease forever. And then we notice as we move up the graph, right here is where the graph stops. So that's where our range kind of stops as well. I'm just going to roughly round that to 8,000. So we can either use interval notation. Our graph goes from negative infinity, these are our y values, up to, but not quite, including 8,000, so that's why I'm going to use a parenthesis. Normally, I would try and find a more precise value and use the bracket, but in this case, I'm just doing a rough estimate. So our inequality notation would be y is less than 8,000. Again, I would try and find a more precise value and use that or equal to, but I'm just doing a rough estimate on this one. X-intercepts occur where the graph crosses the x-axis. Remember, our x-axis is the horizontal axis. In this case, we have two x-intercepts, ordered pairs. First one is roughly 0, 0. Second one, and remember that x value comes first. It looks like it's about 125, and our y value is 0 when we're on the x-axis. Our y-intercept occurs where the graph crosses the y-axis. That's our vertical one. We had an x-intercept at 0, 0. That is also our y-intercept. If your graph has more than one y-intercept, it automatically fails the vertical line test, and it would not be a function. Next, we're going to take a look at what the value of the function is for an input or an x value of 40. So we go over to 40 on the x-axis, and we go up to where that hits the graph. And then we read, and it's roughly 7,000. It's just shy of that, but I'm going to estimate that value to be about 7,000. And finally, is this graph a function? Thinking about sliding that vertical line side to side, there is no place that would cross the graph more than once, so yes, this is a function. We're going to practice that same information on a couple more graphs, starting off with the domain. That is that vertical line sliding side to side, what x values are okay for this graph, what x values show up. And again, because of those arrows, this will continue forever, so our domain is all real numbers. Our range, when we take a look, those arrows, it increases forever up towards positive infinity, but we do have this value down here, kind of where the graph starts. There's no graph below. We're just going to roughly estimate that to be negative 310. And since I'm trying to find a more precise value than I did last time, I am going to use that bracket this time, negative 310 up to positive infinity. Or in inequality notation, y is greater than or equal to negative 310. X-intercepts occur where the graph crosses the x-axis, and we actually already have those labeled for us. -4, 0, 0, 0, and +4, 0. Y-intercept, same thing happened as the last time. We have that x-intercept and y-intercept both crossing at 0, 0. Now we're going to find the value of the function when our input is -2. We go to -2 on the x-axis down to where that hits the graph, and it looks like it's roughly -250. And finally, is this graph a function? Does it pass the vertical line test? Are there any vertical lines we could place on the graph that would cross it more than once? The answer is no, so yes, we have another function. All right, domain, this one's a little bit trickier. There's a couple of vertical lines we definitely need to test out. This is one of them, and this is the other one. There's a break in the graph. There's two breaks in the graph. This is called a piecewise function. Notice how on this vertical line, there is a solid dot on both of them. So there is part of the graph there. And again, we've got those arrows going side to side in both directions. So our domain is all real numbers on this one. Thinking about horizontal lines going side to side, we start hitting the graph here at 0. And while there's a break in the graph over here, if we extend that horizontal line, we do hit the graph, and then those arrows are going up forever. So our range on this one is 0 up to positive infinity, or y is greater than or equal to 0. X-intercepts, where does our graph cross the x-axis? Again, we have that x-intercept of 0, 0, which is also our y-intercept, where the graph crosses the y-axis. Notice on part E, this question is worded differently than the first two we looked at. This is asking what is the x value when our y value, or our output, is 2. So this time we are going to go up to 2 on the y-axis, and we're going to look side to side. Notice over here we have an open circle. That is not actually a solution on the graph, so that is not an x value that makes the y value 2. Over here, off to the left, that is where the graph is defined. And so we're going to estimate that to be roughly, I know it's not quite -1.5, but we're going to roughly estimate that x value. And finally, is this a function? Similar to determining our domain, we have to look very carefully at a couple of vertical lines. Sliding side to side, there are two vertical lines, those same two we were looking at for domain, that we need to analyze to see if this is a function. Notice on each of those vertical lines we have one closed circle where the function is defined, and we have one open circle where the function is not defined. So it does only actually cross the graph once on both of those vertical lines. That's the closed circle. Technically, it is not touching the graph at those open circles. So we are okay on this one. It is a function. One last graph, taking a look at our domain. Sliding a vertical line side to side, we start hitting the graph here at -5. And it stops hitting the graph over here at -1. I'm looking at those x values for our domain. So dropping down and reading those values off the x-axis. In inequality notation, we would say -5 less than or equal to x, less than or equal to -1. For our range, we're looking at our y values, thinking about a horizontal line crossing the graph, and reading that off of the y-axis. Our graph starts at -3 and goes up to +7. In inequality notation, that would be -3 less than or equal to y, less than or equal to 7. X-intercepts, where does our graph cross the x-axis? Just before it gets to -5 and just after -1. I'm just going to estimate those to be about -1.10 and about -4.90. Y-intercept, where does our graph cross the y-axis? Ours does not cross the y-axis, so we have no y-intercept. Similar question to last time, what x value gives us a y value of -2? We have two of them in this case, just before we get to -2, so about -1.9. And that second one was just after -4, so we're going to say roughly -4.1. And is this a function? No, it fails the vertical line test almost everywhere we could place a vertical line. We hit the graph twice. Take a look at this U-try. This one, the domain is not all real numbers, so think about where the graph starts and stops, as well as where the range starts and stops. And we'll go through this one when you get to class tomorrow.